Hey, this is Charlie Thompson, and welcome to the Seismic Explorer how-to video. So I'm going to start off just like I was a student. I've got the address. I'm going to put it into Google. I'm going to open it up, and I'm going to go full screen, because that's all we care about. And now it's going to load in. And there it is. So let's get started. What do we have? Map type. So this is the point where you can change your map. There's a street view from ArcGIS. There's a relief map that has a whole lot of texture on the ocean floor. I am going to recommend that you go with the street view, but play around with them. Make yourself happy. And for data type, we've got plate boundaries. We have plate names. Continent and ocean names. Earthquakes are already turned on. Volcanoes, we can turn those on. There they are, the volcanoes. And also plate movement, which gives you both the plate boundaries, the plate boundaries. That's weird. Can you stop plate? Yeah. So plate movement also turns on the plate boundaries. And so let's see, we've got plate boundaries, we've got plate movement. If you click on the little icon, it shows you how fast those plates are moving. There is a legend. It's called the key legend, and that tells you, for example, the color coding for the earthquakes, telling you how deep they are. The magnitude, the energy released in the earthquake is shown by how big the dot is. The plate boundaries are color coded. Yellow is a convergent boundary. Magenta is a transform boundary, and green is a divergent boundary, a spreading center. And the length of the arrows tells you how fast the plates are moving. So I'm going to leave on plate movement. I've got earthquakes. I'm going to get rid of that. I'm going to get rid of that. And over here in the bottom left, you can start and you can watch all of the earthquakes in the data record. I'm just going to let that finish. Yeah, that's nice. So, like, that was cool enough. As far as I'm concerned, if the website just did that, I could probably make a lab question out of it, but that was pretty good. So you should be able to, you can grab the triangle and see only recent earthquakes. You can grab the other triangle, the dot, and slide it back. So you've got control over what range of earthquakes you're watching. Down here on the bottom is the magnitude slider, so you could see, for example, only the small earthquakes. Maybe you're into small earthquakes. Magnitude 5. There you go. There's all the magnitude 5. But what if you wanted to see everything that was, let's just say, I don't know, 6? Is that 5.5? If we crank it up to 6. There you go. So now it's everything over magnitude 6. You can slide the left-hand one to adjust the smallest earthquakes. So now we're only seeing the biggest earthquakes. That's part of what you'll be doing today. Let's put that back to all the earthquakes. That's pretty much it. So we got the map type, we got the data type, we've got earthquakes displayed, we've got volcanoes, which I mentioned. It's kind of hard to see the volcanoes and the earthquakes. Nice to see the relationship of the volcanoes. And then if you click on a volcano, it tells you what kind, a stratovolcano tells you what kind of volcano. If you click on the earthquakes, it tells you which plate, how deep, what the magnitude was. And let me turn off the data type, turn off the volcanoes. There you go. So one of the things I really like, and I'm not going to use Brazil anymore. Tired of using Brazil. So the dots, like I mentioned, they're color-coded based on depth. Open that back up. Red are the shallowest earthquakes from 0 to 30 kilometers. Orange, 30 to 100. Yellow, 100 to 200. So what we see here, if I turn off the earthquakes, there you go, you can see that there's a convergent boundary. I'm going to turn all the earthquakes back on, and you can draw a cross section. This is, I think, the coolest part. So I click on it, and now I've got little crosshairs, and the little purple dot is just so you can see where my cursor is better. So you click, drag, let go, and it'll create that. And then if you click on what you clicked on the first time to draw the cross-section, open 3D view. Oh, so we are very clearly seeing a subducting plate. We've got a subducting plate. Whatever this plate is there's a little view. You could tilt it up, although we're in the middle of the ocean, so that's not super helpful. You can click and drag and rotate. You could look at it from below. I don't know why you'd want to. Side view, top view. Top views are kind of interesting, and you'll probably want to make use of that because if there's details on the map, they could be helpful to see. So again, the earthquakes are color-coded by depth. So we've got some, in fact, there's a scale, 200, 400, 600 kilometers down. So here we've got the shallow, still shallow, intermediate, and then really deep earthquakes. I'm going to close the 3D view. We're back here. Right, that was all offshore. So let's cancel that to get rid of it. And if we found another example, oh, sure. So I'm going to click on the draw cross section, click, drag, open 3D view. And now we've got a cross section across, and you can see it's different, right? That the depth, there's nothing over 300 kilometers, nothing over 300 kilometers. That's interesting. A side note that I find cancel that. I was going to say a side note that I find super duper interesting is that the older a plate is, for example, the Atlantic, so this is like baby crust in the middle, and then the oldest crust is over here. So the older the crust is, the colder it is, and the steeper the angle is as that crust subducts. So for example, zoom out just a little bit. There you go. Draw a cross-section across this oceanic trench. Oceanic convergence. Open up the 3D view. And it'd be really nice if we could plot what the angle of descent was, that the steeper this angle is, the colder the slab is, the older the slab is. You don't have to do that for this lab. Don't be concerned about that. I thought about trying to make it, but since we can't actually measure the angle, it just didn't seem like there was an easy way to do it. So I think that's everything that you're going to need to know how to do for this lab. That covers how to change the mat type. Satellite's pretty cool. I would recommend that. And yeah, sometimes it's fun, like I said, to turn off the earthquakes and just look at volcanoes. I didn't want to do that. Cancel that. So now we've got volcanoes with convergent boundaries. Yeah. Convergence. Oh, right. So this was interesting. I knew there was something else I wanted to show. You can't see the cross-section without the earthquakes turned on. There's no tool to draw the cross-section. I'm so glad I spaced out on that. Draw a cross-section. Cool. Let's draw a cross-section across the southern part, because I don't think we've done that. And the part that I thought was really interesting was not only looking at the depth and the angle of the plate, but then seeing, and this is what I was talking about, so you can see these volcanoes are actually the Andes Mountains. And so you can see how far down the plate is getting before it melts and then bubbles back up. So looks like all the volcanoes are pretty much over the yellow dots, which would be 100 to 200, although it really looks like they're closer to 200. Or is that just yeah, I'm going to go closer to, anyway, play around with that, but you can't see, you won't have the open 3D view unless earthquakes are selected. I don't know why it does that. Doesn't make any sense. Anyway, that's that. I hope you get a kick out of, I would play around with it a bunch more. You can also click, I think I mentioned, can click to see the rates of movement of different plates. San Andreas Fault cranking along at 51 millimeters, 5.1 centimeters a year. You can see how different parts, for example, this part, cancel that. So this part of the Atlantic is spreading apart at 23 millimeters a year. And this part of the Atlantic is spreading apart at 33 millimeters a year. Interesting. Yeah, that's enough. I hope you enjoy the Seismic Explorer. I hope you use it to explore seismic features.